Good evening, everyone, and thank you, Nidhi ji, for giving this opportunity for the session. I have a very empowered panel over here, and we are going to discuss about the future of blow molding. I come from a user industry, and to me, what I'm looking forward for this session are key future trends that are possible for blow molding. Blow molding, if you see, it's the most versatile packaging conversion process in which you can actually get a hollow container right from even 2 milliliter to 50, 100 liters. And this is a kind of technology which is also a very cost optimized and cost effective for all the end users and consumers. What I would like from this session, and we would be looking at like 3 trends, key trends. One is a sustainability, one is the efficiency, and one is an innovation. In sustainability, we are getting, and we have seen this across the last 2 days, there are various biopolymers, new polymers that have come up, and how blow molding machines, processes are geared up to handle these polymers. That is one line of very interest, including the recyclable polymers. Then comes the efficiency, where we talk about the advancement in automation, machine learning, and process optimized various high-end equipments, how it will lead to more efficient blow molding operations, which will reduce both energy and waste. And the third and the most important thing would be innovation.
Cover some of that. So today I'm very proud to announce that at Creative we formed a think tank called Future Plastic Think Tank. And in this think tank, we've invited a number of, CEOs, investors, policymakers, all to help guide us as to what the future of plastics is going to look like. And I'm very proud that today is the first public demonstration of some of the work that's come out of this think tank. So I have the privilege of presenting that. So before I get into it, just to tell you the logic of why this presentation has come up is, at conferences like this over the last 5 years, many speakers, including myself, have always talked about how plastics is a wonderful material, how it's not fair that plastics is made to be evil and villainized and demonized, and we are very proud of plastics, and we should be. But the problem with that, and it's an uncomfortable truth, is that speakers like myself can only say that in a room like this. This is the only kind of room where people will listen to that and appreciate that. So what we believe is that we really need to reframe the way plastics is thought about, and part of that comes from the economics. So that's going to be the argument that we are making today, is that we need to reframe the entire conversation of what is happening with plastics. So just to give a quick intro to Creative, I won't take too much time, but so Creative, we have a technology-driven approach to blow molding. Our founder, Dr. Agarwal, has a PhD in polymer science. Our entire management team, we're all engineers. We've been in the business for about 40 years, so we're one of India's oldest blow molders, and we're one of the largest as well. We have expertise across blow molding technologies as well as injection molding. So essentially, we make any kind of rigid package that you can think of. We have a very strong culture of innovation and a strong culture of sustainability, some of which you'll see today. We're very proud that we're one of the few Indian companies to have a global presence. So we have plants not just in India, but across the world. And we're also very proud that we remain today a 100% family-owned business and 100% debt-free.
Good afternoon to all. I would like to take you... good afternoon to all. I would like to take you to a small journey of sharing regarding the importance of optimizing resources in the plastic molding value chain. I know that everyone would have done something or the other in their businesses, but it would be great for me to share about some excellent work which we have done in this area and share our experiences. So let me start by introducing SSF first. and then share about some insights about how various measures are taken to optimize the resources at SSF. So SSF was founded in the year 1985, headquartered in Mumbai, has 17 manufacturing locations, and we do run technologies across injection molding, IBM, EBM, and ISBM. And we do a lot of various post-molding activities and decorations too. We are constantly upgrading ourselves by upgrading our technologies. At SSF, our resource optimization strategies are not just theoretical, but are practical solutions that drive our operations. With over 325 molding machines, we process about 40,000 metric ton of polymer, and which results in more than 3 billion injection molded components and about 1 billion blow molded components. This showcases our tangible outcomes of the resource optimization efforts we do at SSF. So, firstly, I will speak about the introduction to resource optimization, which will cover the importance of resource optimization. Next will be co-creation and collaboration, resource optimization, empowering our people, automation and process improvements, sustainable practices, and lastly is enhancing sustainability and giving my final thoughts.
Gathering all the industry leaders in one place so we can actually talk about the current situation in India, talk about what problems producers are facing, and technologies that can assist and enlighten people to be able to move forward. So very happy to be part of this conference. As he mentioned, I'm Sudha Jebadurai. I'm basically from India. I've been in the United States for 25 years, working with AGR International. But my passion is still India because it's my hometown. As I see India getting to be a global producer, getting to have an economic growth that is way higher than any of the other countries in the world, it is the place to be. It is the place to make sure we do things right so we can actually make progress as we look ahead. AGR is a leading global sustainability partner for the packaging market. And we also supply quality control machines for both glass and plastic markets, rigid packaging markets. Thank you, Mr. Chakravarti, for the kind introduction. And let's go ahead and get started. Okay, thank you. Okay, a very quick introduction on AGR. AGR has been around for nearly 100 years. We started in the glass market, and our forefathers, our founders, were basically research engineers. So we are based in science, and that's what we're proud of. AGR actually wrote a lot of the quality standards for the packaging industry. And so we normally say, why do we need to do a certain test based on the properties of the material, and then we develop testing standards for it. So in the 1980s when the...
Good evening. Actually, I'm delighted to see hall is full. So it is Nidhi's magic, postponing the tea break. Actually, I was waiting for the tea. I have to come here rushing. So thank you very much for inviting me and making me to present Elite Plus Plus Plus. So I will run through a couple of things. One is introduction to Uniloy, Uniloy India, then the products, what we make, quick introduction. After that, we will maybe walk through about the innovations, what will be used, can be used for making you more profitable, and what are the future trends which will come in India, products. Then lastly, multilayer, which is talk of the day. So we can reuse, that means PCR, we can reduce by some innovation techniques, or we can reduce the material weight, cycle time. So we'll go through one by one. And I hope I will be able to complete within time frame. So first introduction to Uniloy. Uniloy is a global company having manufacturing footprint in North America, Europe and India. And we have worldwide sales services, offices. Here is the Uniloy India. We were operating with Milacron since 2006. And we made many machines supplied to domestic as well as exports. And we have already started our own factory, own setup from this year. And we'll be building machines with our own team. And we will be delivering, dispatching, supplying the machines made by North America and Europe. So high-tech machines basically. And the beauty of the Uniloy India is maybe we can design to everybody's need. We are flexible and we have maybe special flexibility on pitch and cavitations. So these are the products made under umbrella of Uniloy, which includes UR series, very high speed series. You can see high volume, high speed, lightweight, multi-layer capabilities. And A series is basically industrial product for automobile furniture.
Technologies, PCR material processing, barrier applications, and a little summary. Company overview, keys and facts. We are a very small business based in Germany, almost 50 years on the market. We are making extrusion heads and extruders for extrusion blow molding and only extrusion blow molding. Our products by now in 54 countries. We have an installed base of 5,000 heads worldwide, making very small medical products up to 1,000 liter or more containers. We have a capacity of making approximately 120 heads per year, and the turnover we do out of Germany is, or the revenue we do out of Germany is 15 million, and we have about 100 employees. So it's a small business, it's a niche market that we are dealing with. Those are our locations, production and development facility in Germany, and then we have W. Müller USA Incorporated in Massachusetts for sales and service of North and South America. Multilayer technologies. On this picture you see one of our multi-layer heads. You see the head and the extruders. We make the complete package turnkey. So today we're going to talk about two multi-layer technologies. One is the two on the top, left and right, deco and reco. We call it decorational co-extrusion and regrind co-extrusion. And the other is coex 4 and coex 6. You see on this picture, which we already have seen in the previous presentation, the most common barrier configurations. There's more, but today we'll only talk about 4-layer and 6-layer mostly. So when we, just to explain our nomenclature, when we talk about coex, then we talk about the barrier, and therefore we use adhesive, and the other one is the regrind co-extrusion and the decorational co-extrusion. I think most of you know how multi-layer works, but I brought this little video to give you an idea how a multi-layer head works. This is a 3-layer head. We have the head here. It's a single Parison head. You can see there's a manifold system, and the manifold system is fed by, in this case, by 3 extruders. We have the inner layer, that's the green one here. We split up, go into the inner insert, heart-shaped curved pinola, whatever you